This conference will now be recorded.
All right, hello everyone, and welcome to the Satellite Book Club seminar series. The title of our talk today is Rethinking Mesoanalysis for the Modern Era. Our presenter is Todd Lindley, the Science Operations Officer from WFO Norman. Our facilitator today is Randy Bowers, lead meteorologist from WFO Indianapolis. Before we get started, just a few announcements. As usual, the session's being recorded. We will be having Q&A at the end of the presentation. We encourage you to place your comments and questions in the chat room, and we'll field them from there at the end, toward the end of the talk. Most of you are already doing this, but please sign in if you're not already doing so with your full names, so that we know who's attending the call, and we can follow up with you if needed. And also, especially for those maybe are expecting but not receiving or have stopped receiving TowerS messages, we've learned that sometimes the messages are redirected to your spam folder. So please check there if you haven't heard from us in a while. As usual, we're looking for future presenters. Please contact the TowerS team. Contact information will appear in the slides ahead. And if you would like assistance or guidance on preparing training materials, please contact Brian Mata for questions regarding that. Thanks as always to the TowerS team, Kashad Bowman, the Office of the Chief Learning Officer, GOES-R and JPSS programs, our facilitator and presenters, as well as all of you attendees. Todd's going to begin in just a short moment here, but just a few words before we pass the mic over to Todd. As mentioned earlier, he's the SU at WFO Norman. He served in the Weather Service for 27 years at WFOs across Texas and Oklahoma, and is a graduate of the University of Oklahoma. Todd, welcome to the Satellite Book Club, and please begin as soon as you're ready.
Thank you, Brian. If my bandwidth gets a little sluggish, just interrupt and let me know, and I'll turn the webcam off. Hello, everyone. Thanks for attending today. It looks like you guys have a full house up at Indianapolis. Randy said that there are no parking spots left in the parking lot. So it looks like that's great to see. Appreciate all you guys attending. We're going to talk a little bit today about rethinking mesoanalysis for the modern era. Really on behalf of WFO Norman, I guess I'll carry the primary message here. And then Randy's going to co-present with a few slides from a case up in Indianapolis as well. So let's get started. I think we frequently hear two popular misconceptions about mesoanalysis, certainly in the National Weather Service. One is we do not have the staffing to dedicate to mesoanalysis, and or we do not have the expertise in a local office to do mesoanalysis. And I'll post a contrarian opinion here and challenge everyone a little bit. If we look at the NWS meteorologist position description, it says that we're to conduct a weather watch that involves interpretation of Doppler radar, satellite, and analysis of other hydrometeorological data for preparation of all warnings, forecast, service products. So I would challenge everyone to rethink this, that we are always doing mesoanalysis, and we probably shouldn't get distracted by the terminology that we're using. But if you're the aviation forecaster or you are the short-term forecaster and you're conducting a weather watch, then in some sense you are conducting mesoanalysis all the time. If we look at the AMS Glossary of Meteorology, and I'll paraphrase their definition of mesoanalysis, it's the representation of temperature, moisture, pressure, and wind variations on a horizontal scale of 10 to 100 kilometers, and that it seeks to define features that can be related to important local and regional circulations that may in turn have a significant impact on a local or regional weather system. I'll kind of rephrase that for a practical operational definition for our discussion today and focus on the application of conceptual models to bridge the gap between observations and high resolution numerical weather prediction, all while coordinating and communicating actionable intelligence, specifically in the 0 to 6 hour forecast period. So a very simplistic view of this modern definition of mesoanalysis might include bridging the observations to model gap and extending the effective lead time for evolving hazards. To me, that's the primary objective in conducting mesoanalysis, is to effectively extend that lead time for all hazards that we're communicating to our partners. So in operational reality, there are a lot of tasks that need to be accomplished in a WFO in real-time operations during hazardous weather. You have, of course, someone dedicated to warning, someone dedicated to communications through various channels, NWSChat, social media. Someone has to continue doing the routine forecast, right? The upper air balloon has to fly. So mesoanalysis, understandably, frequently gets load shed. It's certainly distracting, and sometimes, unfortunately, it probably gets eliminated in a local WFO when it's needed the most. This is really analogous to lining up and taking a snap without your right guard. Okay, it's leaving a huge vulnerability in operations. In fact, I would argue that mesoanalysis is an integral part of the warning operations, and it really cannot be removed from the core set of operational duties that must be conducted during severe warning operations. In fact, you really need a seamless flow of communication between the folks that are dedicated to warnings, whether you have 2, 3 warning forecasters, the mesoanalysis and the communications that are going out from the office. All of this has to be coordinated. So how do you lock in the mesoanalysts, and how do you keep them focused on task to conducting mesoanalysis? And by the way, sometimes you may assign someone to be the mesoanalyst, and they may have this idea that it's a very nebulous or abstract task, and they may not know exactly how to focus the information that they're obtaining through their mesoanalysis. So what we have done at WFO Norman is to focus on mesoanalysis being tied to a deliverable. And for the mesoanalysis to be meaningful, it must be communicated through one of these deliverables, specifically maybe a mesoscale updated AFD or messaging in NWSChat. Or what we really focus on a lot would be watch to warning graphics, or what I call meso messaging, that can be quickly and efficiently communicated in social media. But it's really, like I said, an integral part of the warning operations, and everything is designed around getting mesoanalysis to effectively increase our lead time in our messaging. So here's an example of a spectrum of messaging that occurred prior to a flash flood event in the Oklahoma City metro area. And you can see all the way from, QPF forecast very early in the day to flood watches being issued on the kind of a meso scale to eventually at, let's see, it's not transitioning, there we go. Eventually around 3 p.m., a social media graphic was issued. This is what we call a watch to warning graphic with an increasing flash flood threat at about 6 p.m. And this was more than 3 hours prior to the actual flood event on the north side of the Oklahoma City metro area. So this is the type of messaging that I'm talking about, where you're translating mesoscale analysis into something actionable. So what does modern mesoanalysis really look like? Well, it can include SMEs facilitating real-time support, and really importantly, post-event learning opportunities, so that everyone in our agency, we get to kind of spread the wealth of the experience that we've gained through working events and translating that into more actionable science and information. The goal is to contextualize and downscale INCEP outlooks and or information from the numerical weather models, and to really refine messaging. As you can see in this bottom example of an enhanced risk from the Storm Prediction Center over central Oklahoma, but a vast majority of the impacts that day were displaced out to the west of that enhanced area. So this is the type of downscaling that we need to be focused on in mesoanalysis. So this is the Satellite Book Club. So I want to talk a little bit about how satellite, while it's not necessarily the only tool used for mesoanalysis, it can be a very key and effective tool used in mesoanalysis. And you can see from this example, just looking at the nature of the satellite imagery and the clouds detected. You can distinguish the surface-based areas where convective initiation may be imminent, and you can kind of contextualize or visualize how that relates to things like proximity soundings or forecast soundings. To the north of that boundary, you see faster moving mid-level convection that's not rooted in the boundary layer. And then further to the northeast, you see more laminar cumulus fields where the atmosphere is strongly capped. So all of these clues can be derived from satellite data. So we'll take a look at this example from western North Texas in April of 2021. And if we loop this, a couple things you will see based on our mesoscale analysis from the Storm Prediction Center and other sources, surface obs, you can see that there's a dry line intersecting a warm front over western North Texas, and that warm front extends east just south of the Red River Valley. And in the satellite data, you can really see the difference between the billowing clouds to the north and the more unstable Q to the south. And in fact, one of our forecasters picked up on that very early in the afternoon, pre-convective initiation, and started to focus on this transition between stable billow clouds to the north of the boundary versus vertically developed Q to the south. And if you recall from the training, hopefully we all took on the mesoscale environmental analysis training, one of the modules in there on using satellite imagery highlighted that as a conceptual model or a threat area for an increased tornado risk. And of course, just to acknowledge, this is the cloud phase RGB that distinguishes the cloud phase from liquid water to ice, and it's a very useful tool in doing this type of mesoanalysis before convective initiation. As we progressed through the afternoon, storms started to initiate, and you could start to distinguish early observations of the objects that were defined in the CAMs, and specifically in this case in the Warn on Forecast System guidance. So you have incipient supercells that you can roughly match to, okay, this is the object that the CAMs are seeing or that the WFOs is seeing, and this is how it projects it out in time. So it's really taking these early observations of CAM-based objects in the remote sensing, using that to extrapolate out in time to make effective mesoscale messaging. And a real quick note here on WFOs, if many of you probably have developed extensive experience with it, but if you haven't, I just want to make this little statement that WFOs really is a very unique hybrid system that spans observations and CAMs. I think early on in its proliferation, we kind of marketed it a little bit as a CAM, and really no different than the HER. But because it's constantly ingesting new radar data and new observational data, it's really more of a hybrid system, and it tends to learn and catch on to a situation and adapt, unlike a typical CAM. Okay, so to continue forward on this particular case from April 23rd to 21 in Northwest Texas, there's a whole spectrum of messaging that occurs from the time forecasters first identified that enhanced zone of potential along the boundary in western North Texas. You have a tornado watch that was issued shortly thereafter. You have specific mesoscale discussions from the Storm Prediction Center, and then you have CAM input refining that to the point where around 4:11 p.m. that afternoon, WFO Norman issued a watch to warning social media graphic that highlighted the increasing tornado threat within a narrow corridor of western North Texas that included some communities like Kewanna, Kroll, and Vernon. And this was actually 92 minutes prior to tornado genesis. So, you know, clearly that's on a scale beyond your typical tornado warning. You're not going to issue a tornado polygon out that far in advance and over such a broad area, but it really helps focus down from the scale of the watch to the scale of the warning in that critical 0 to 6 hour time frame where there just isn't a lot of messaging traditionally going out the door. Randy, we'll pass it over to you for a winner case from Indiana.
This was an interesting case, and it ties in with a lot of what you already talked about, Todd, about how, you know, we're really trying to broaden mesoscale analysis. It's beyond now just what we used to think of it with supercells on a dry line and in the plains maybe on the high risk or moderate risk days, but we're really trying to get this involved with winter weather and other examples that I know you have another example coming up here pretty quick. But just real quick, I don't want to get too deep into the details with this one, but I wanted to mention it was an interesting case where we watched it evolve. It was about a month ago here for Central Indiana, the Indianapolis office. We were really hitting the mesoscale pretty hard, and just really being able to update the forecast beyond just overnight shift, which did the forecast package. Matt and I were on that. But just to kind of continue on into the early and mid-morning hours, we were able to look at satellite data and track the progression of the mid-level low and where the dry conveyor belt was and refine the forecast based on that. So if you want to go to the next slide. Okay, this shows, if you look to the right, and on the left, obviously that's a conceptual model of the the dendritic growth zone and how the temperature range within that makes a big difference for snow liquid ratio. That was the challenge with this particular event. And if you notice the sounding on the right as it animates, it sort of shows that it basically, one of the earlier model runs was much more deeper with the moisture, and there was a lot of ascent and moisture within the dendritic growth zone. But that changed with time. As everything shifted just a little bit, suddenly now we have a shallower layer of moisture, a little more convective instability. And so the way that if you use the top-down method, it really changed in just a matter of 12 hours with the models. So we were able to watch the observational data and make adjustments on the fly to that and realize we weren't going to have nearly as big of a snowfall event as we thought that we would with that particular case. So if you want to go to the next slide real quick. There's a lot of text on this next slide. It's just to show that we did a couple of key mesoscale updates in the early morning hours. So don't get too caught up in the text, but really wanted to kind of make the point there that in the early morning, and then there were a couple more we did into the mid-morning time frame, that if you pay attention to the times we sent those, it wasn't just this rigid process for forecasting, that we updated the forecast continuously based on the observational data by continuously reevaluating the mesoscale. So, there were some challenges. Obviously, the snow liquid ratio was the biggest challenge, but just placement of the overall system, a few minor errors in the models made a huge difference in the outcome. And really, Todd, that's all that I want to kind of mention with that. So you can take it from there with the next case, and then we'll get the discussion going after that.
Okay, great, Randy. Yeah, appreciate that. And I love, that even though we had some technical difficulties there, we transitioned from a severe convective case to a winter case. And just to continue this theme that mesoanalysis cannot and should not, or should actually apply to all hazards, we're going to go into a fire case real quick. And this was a highly anticipated and well forecasted wildfire outbreak on the Southern Plains back on March 29th. You can see even CNN knew it was coming well in advance and published a story that a significant wildfire outbreak is likely today across the Southern Plains. And that's because it fit the conceptual model for what is known as the Southern Great Plains wildfire outbreak here on the plains. So SPC had an extremely critical area. Like I said, it was well forecast here regionally in the Southern Plains, and ultimately 29 fires across 4 states that day burned over 100,000 acres. 26 structures were lost and three people were injured. So a high impact event for sure. On the subsynoptic scale, we had what we call a fire effective low level thermal ridge that was in place over western Oklahoma and the eastern Texas panhandle. This is a known aggravator for new fire spread or new fire ignition and very rapid spread and extreme fire behavior here on the Southern Plains, because it basically sets up a natural blowtorch effect on the windward side of the low level thermal ridge when a fast mid-level speed max is overspreading it from the west. So we could see that this pattern was setting up thanks to cams and observational data from the West Texas Mesonet showing a fire parameter in use here in the Southern Plains called the red flag threat index, hitting extremely critical values of 7 and 8 on the windward side of that low level thermal ridge. So through that, the use of those conceptual models and applying the observations to the cams through those conceptual models, we're able to say in a meso messaging graphic out to our partners, showing them where ongoing fires were occurring, but also saying that the low level thermal ridge is amplifying along the 100th meridian, which is basically the Oklahoma-Texas state line there in western Oklahoma. The most likely areas for new significant fire ignition and spread will shift eastward toward the eastern Texas Panhandle and far western Oklahoma in the next 0 to 3 hours. And then if we animate the shortwave IR imagery here over a 2-hour period, from that time, you can see the ignition and initial spread of two 30,000 acre complexes right near the Texas-Oklahoma state line, and an additional 10,000+ acre fire coming out of eastern New Mexico on the southern tail of that atmospheric feature. So in summary, just rethinking mesoanalysis, what I would really hope that you got out of this today is that mesoanalysis is an integral forecast and warning operation. It's part of the warning process. It's intended to bridge the observation to model gap with the sole objective of increasing lead time for all applicable hazards. And it must be tied to and effectively communicated in some form of deliverable, whether that be a mesoscale update discussion through NWSChat, watch to warning or meso messaging graphics that can quickly be disseminated. The bottom line is to communicate what we know, when we know it, and that mesoanalysis can't occur in a vacuum and must be communicated effectively. So with that, I know we went just a couple minutes over, but that's all we have.
Good stuff, Todd. Really important conversation to have. I feel like, we have the same thoughts here at the Indianapolis office. I know a lot of the other offices do as well. So let me just mention that, we want to encourage, obviously, anybody that's participating, regional headquarters at the field office that's on the call now, to basically, add their questions in the chat. Please use your full name if you can, and that'll help us facilitate the discussion that we'll have here shortly. So now let me mention just real quick, and I know Lee's going to put a survey link in there for feedback, so feel free to fill that out as well. But let me also mention what we have coming up next week. That's going to be on Thursday, March 2nd at 12 p.m. Eastern Time. Matt Gunshore, a researcher with SIMS, will discuss the difference between GOES 17 and GOES 18. So we look forward to that. And again, that's next week, next Thursday, March 2nd. Also, just anybody that has any questions about anything related to satellite and information about how that gets into AWIPS, the TowerS team is excellent. They'll provide information. Feel free to reach out to them. Lee Byerly or Kashad Bowman will be able to answer any questions. So don't hesitate if you do have questions on that. So for the discussion, was going to kind of mention here real quick that it's, we're honored to have the TowerS team here in Indianapolis. So we'll have some questions that we'll take from the audience that are actually here in Indianapolis. We have a couple people from surrounding offices that have made the trip to Indianapolis too. So, but we don't obviously want to leave out the people that are online too. So a lot of questions are coming in from people that are, obviously virtual too. So keep typing those in. We definitely want to hear those questions, and we'll get through those too. But what we may do is we'll just go with a couple questions here, and then at that point we may cut the recording, and then we'll kind of get into a little bit more deeper discussion after that. I was talking to Kashad and felt like that would be a good strategy given what we got. So the first thing that we had come in was from Steve Goodman. Basically had mentioned that there was a situation recently in the Tennessee Valley that there was a lot of severe weather. It ended up being more of a flood threat. So this is just one of these cases. We deal with these quite a bit. I know exactly kind of what you're talking about there, about how it transitioned to be more of a flood threat than what was expected and less of a severe threat. So the question then was kind of how did mesoanalysis help to communicate that? And so Todd, you may not be able to answer that directly, but I know we've dealt with that in Norman. So can you give some perspective about those type cases that just suddenly shift, and now we're dealing with a whole different type of weather threat than we thought with before, and how mesoanalysis can help with that, and especially on the messaging side?
Yeah, sure. And of course, I can't speak directly to that particular case, not being involved in the operations there for that. But yeah, I mean, that's a common theme that you see unfolding in mesoanalysis. And many times we know going into an event, right, that early on it may be a supercellular tornado event that may grow upscale to a QLCS, and then maybe even eventually maybe transition to a flash flood threat. So that's absolutely key part of the forecast and warning operations would be for the mesoanalyst to key in on when the environment is supporting that change and evolution over time, and giving the integrated warning team, if you will, a heads up on that transition. We've seen many cases, Randy, as you know from your time here in Norman, where you have tornadic supercells over western Oklahoma, but the threat's going to transition to more of a flooding threat as it gets into the populated areas of central Oklahoma. So you want to be ahead of that transition and message that through our partners, really kind of guiding the messaging on that and letting them know, okay, you're seeing really big tornadoes on TV now, but when this gets into central Oklahoma, it's going to be more of a heavy rain threat.
Yeah, exactly, Todd. We've all been through that, and that's one of the examples was the case that we had in Indianapolis is very similar to that, where we had to just, and Matt Foster made a really good point about that too, about how changing at mid-course is difficult. It's a challenge trying to figure out how to do that, but we've had, that's what, if you've got the science, the mesoanalysis is there, then you can start to really transition that messaging as needed. So it is a challenge for sure. I was going to ask one more quick question too, to kind of throw into the conversation. What kind of feedback are we getting on this, Todd? I don't know about your office. We've had some here, but we're really trying to drive the message better. So have you had any examples in Norman about feedback from the partners and end users for what we're trying to do with mesoanalysis and this meso messaging?
Yeah, sure, Randy. That's a really important point. And one thing I'll touch on in answering that is, as we go further down this probabilistic messaging and meso messaging route, how do you even define lead time, right? I can think of one particular instance, the Elk City tornado a few years back out in western Oklahoma. That's a case where, if you look by the definition and technically at our lead time for Elk City, that tornado occluded, curved north very sharply to come into Elk City. We actually lost it out of the northern boundary of the polygon and only had an official 6-minute lead time for the tornado in Elk City proper because of that. But because of the meso messaging we were doing in advance, the emergency manager there had been sounding the sirens for 30 plus minutes, because that was a case where we had our meso messaging focusing on a very narrow area of tornado potential well in advance of the storm, about 90 minutes out. So based on that, they were taking actions already. They effectively had a much longer lead time than what you got with the official tornado warning.
Yeah, that's a really good example, Todd. Brian made a good point here too about how this really starts with the local office management culture too, and for them to kind of reinforce mesoanalysis and that region, and just when we're all on the same page to really kind of get on board there, it's really good to kind of push that idea that mesoanalysis is really key. Brian down in Midland made that comment too, so really great there. Let's see here. A couple more comments coming in. Again, please feel free to add comments, questions into the chat, and we can get to those. We've got a little bit of time left here for sure. Tyler Snyder had a comment in here, mentioned about leveraging computing power and simulating observations to give us a clearer picture of the meso environment. So there's a modeling component to this too, and so he's kind of asking about that. I don't know if you have a perspective from Norman, Todd, about some of the newer modeling ways that we're able to kind of get into the mesoanalysis a little deeper with that or not.
Yeah, in general, I think, Randy, my comment on that would be it's a constant challenge to put the right information in front of forecasters at the right time. I think we need to think outside the box. My title slide had a picture of our ops area, and you could see all the things on our video wall that's in front of the forecasters, and it's a constant challenge to make sure that we have the appropriate data and it's presented in the appropriate format to be utilized for good mesoanalysis. And I mean, that's a challenge we're constantly trying to innovate. For instance, Cameron Nixon's latest plots that have been added, I think, that show the hodograph and plan view, right? I mean, that's a very nifty example of kind of rethinking the way you can visualize data for mesoanalysis.
Yeah, excellent point there, Todd, for sure. Anybody in the room here at the Indianapolis office? I know we have several people that may have perspectives or questions or comments to add to it as well while we wait for additional questions or comments through the chat. Anybody have anything? All right. So far, nothing from here at the Indianapolis office, but let's see here. Do we have anybody else with any questions or comments? If not, we can wrap up the discussion part and toss it back to Brian.
Okay, thank you, Randy, for facilitating, and thanks, Todd, for this excellent informative talk. I always like hearing how observational data are leveraged and can be used to fine-tune events as they unfold and adjust our messaging to partners accordingly. Um, as Randy told us a little earlier, next week on March 2nd, we'll have Matt Gunshore speaking about differences between GOES 17 and GOES 18 data, so please join us for that. Wanted to thank everyone, and in particular, I overlooked thanking the folks there at WFO Indianapolis for launching the Satellite Book Club from there this week. Whether Indianapolis is your home office or whether you join them from one of the neighboring offices, we thank you for your participation. Our TAURES team, Lee and Kashad there, are there in part to listen and learn. They take back what they hear, and so we want to hear from you if you haven't already provided feedback, what's working, maybe what's not working as well as it could be, suggestions, maybe data you're aware of that you're not seeing in AWIPS, satellite data in particular being our focus. We welcome your feedback, and while we can't respond to everything, we do our level best to we weigh your feedback heavily and certainly accommodate that into the projects that we take on and execute. And by the way, Lee Byerly knows more about those satellite menus and everything going on under the hood than almost anyone else on the planet. So don't let him slip out the door if you have any questions on your satellite menu or satellite data. With that, thanks everyone for joining. If there are no further questions or feedback, we thank you again for your participation and look forward to seeing you next week.